a quick webinar on frost alerts and protection with HOBOnet. So with you today, I am Richard Rodriguez. I've been with Onset. Actually, I'm coming up on my 1-year anniversary, leading the market for outdoor and agricultural products. I've got some experience from working with growers and researchers, different universities and environmental agencies. With me today, actually, I will have a partner in this webinar today, Matt Sharp, which has quite a bit more experience than I do here at Onset. He's actually leading applications, we're the leading application specialist for agriculture and environmental applications. He's been with the company for a good 6 years, 4 of which in technical support. So, you know, if you think you've got a tricky application, Matt is the guy to talk to. His direct line and email are listed there. A few housekeeping points. The webinar will be recorded or is being recorded and will be available for viewing later in the next day or two on our website. So feel free to share this with any colleagues, friends. Again, it will be on our website, and you should get a notice when that is available. If you do have any questions, as I mentioned, we will have time for questions at the end. Please don't hesitate to enter any question or comment into the questions portion of the control panel. And for those of you new to Onset, we have actually been manufacturing and designing data loggers since 1981. So, you know, not a very old company, but not a new company. So, you know, we've been trusted by environmental researchers to provide durable, trustworthy products that will withstand harsh environments, from the top of a high mountains to seaside applications, and always collect and provide data when needed. We do have a global network of distributors, so regardless of where you are in the world, odds are you can get our products delivered to you. We all know frost, or I expect that everyone on this is familiar with frost and the issues it can cause, but I do want to provide a little background. As we know, I think a little background will help actually in understanding how different measures to protect or mitigate the concerns of frost can help. We do have, in talking to a lot of our customers using our products, we know that cold nights cause growers of early blooming fruits such as strawberries or blueberries, and then late harvesting fruits such as cranberries and apples to stay up at night and lose sleep over the potential for frost damage. Fortunately, there are different ways to mitigate or prevent damage from occurring. So on a typical day, as most of us or all of us know, air temperatures are higher at lower elevations. Closer to the ground, temperatures are warmer, and these air temperatures decrease as elevation increases. Because warm air is lighter than colder air, the warm air near the ground will rise, and cold air will replace it near the ground. During the day, the sun will warm the ground, but at night, you don't have the sun to warm the ground, so all that warm air, all that warmth that is captured by the soil is actually transferred into the air, and then it rises into the atmosphere. On cloudy nights, the clouds actually reflect a lot of that energy back onto the ground, helping keep those temperatures from dropping very low. However, on calm, clear sky nights, that there's nothing to acting as a blanket or radiating heat back towards the surface of the earth. So all that heat is really lost, escaping into space. So on these types of nights, temperatures near the surface really drop, and it creates the potential for a cold air layer to form at the bottom, real close to the ground, and that is then trapped by warmer air up top. And this is what is known as an inversion. So if you can see on your screen the difference between your typical day as temperatures decrease as you increase in height, with an inversion, which is typical of what you would get on a frosty night. That cold air is trapped and remains above your crops, and is what can lead to damage. Now, often freeze and frost are used interchangeably, but they're actually two different events. So in the case of freeze or advective freeze, also known as windborne freezes, these take place when cold air moves into an area, bringing with it freezing temperatures. It's associated with high winds as a cold front moves into an area. Because of the wind conditions and the height of the cold air layer, which can range from 500 to about 5,000 feet above ground, it's really difficult to protect crops from this type of cold weather. On the other hand, and radiation frost, or what we typically refer to as frost, as mentioned in the previous slide, this occurs with calm winds, so under 5 miles per hour, and the column of air, or the cold air, is actually quite shallow, so it's about 30 to 200 feet in height. This condition also leads to cold air drainage, which is basically, if you think of cold air being heavier than warmer air, it settles down near the ground. It actually flows like water, and finding low-lying areas to pool in. Any obstructions, such as walls or buildings, can trap that cold air and create pockets of greater cold. Something to keep in mind when determining where to plant, or what locations to select for certain crops, and where to deploy temperature measurements. With freezes, as mentioned, it's actually really hard to protect the crops. The high winds interfere with the ability, for example, for those of you using water to protect crops, that the high winds make it very hard, or make it less likely for that to work. The height of the column of cold air makes it so that you can't pull warm air down onto your crops. On the other hand, with radiation frost, you do have quite a few options available to help you succeed. So the most common protection methods that our customers are deploying are wind machines, so large fans to pull warm air from above 30 feet in height onto their crops. Irrigation, so by constant watering overnight, you can protect your crops. And then protective cover, so adding a physical barrier to retain the warmth that the soil collects during the day, to protect your crops. So to start, let me first cover the more passive approach the more passive approaches to frost protection. So plastic coverings can basically help retain the warmth of the soil that the soil collects from the sun during the day, and it keeps that around the plants. It's very helpful for smaller, lower crops and keeping them from experiencing frost. A customer of ours, such as a strawberry grower in Virginia, is using plastic coverings to protect his strawberry plants. His concern is that has been over the past few years that he's found that the month of February has seen large fluctuations in temperature over the past few years, where he's seeing warm weather early, long days of warm weather, which is causing plants to bloom early, but then from one day to the next, temperatures drop, and then he's got a few cold nights in a row, which then leads to him losing a lot of flowers. As he says, it's 70 degrees and breezy on one day and then freezing the next. So on real cold nights, what he started to do is, you actually see an image of that on your right. He's deploying a Bluetooth temperature data logger, and on real cold nights, he'll actually go out and take a look, take a measurement, and see what his strawberries are experiencing. But for the most part, he'll collect temperature data every day, just to verify that temperatures near the plant are not getting dropping too far below where they should be, and thus ensuring that his plastic covers are retaining enough warmth. There are different factors that come into play on the effectiveness of plastic coverings, such as how warm the day was, so how much energy was able to be captured by the soil, and then how much moisture is in the soil. The closer soil is to capacity in water, the better it is able to retain heat. Basically, the higher the moisture level, the more energy it can retain to then transfer to the plant at night. We also have customers using the similar Bluetooth devices to plan where to place crops or select crops for different points on their farm. So ahead of making their decisions, what they do is that they deploy several of these Bluetooth devices across multiple points on a farm, so that they can get an idea as to where temperatures may remain higher and where they become lower overnight. They're looking for spots that are more likely susceptible to frost conditions or see more nights of frost conditions. And then for those spots, they'll choose a crop with greater hardiness or an earlier harvest or later blooming type crop for that location. Just to give you an idea, these Bluetooth data loggers, they start at about $49. We have several options depending on what you're looking for, and they're great because of their size and their features such as sensor placement. They make it easy for you to actually know what the temperature is at the height of your crop. So for a strawberry, you're just a few inches off the ground. Now, looking at the more active approaches, such as wind machines, water, and chemical applications, these frost mitigation methods are effective, but they do come at a cost. The challenge with these methods is that it's either time or money or both. When it comes to applying them on cold nights, for farmers, the options really come down to, well, do I stay up all night watching a thermometer, keep my eye on a thermometer, and hope that I'm correctly accounting for temperature differences from where I'm at and to where my crops are located. You can just spray or water based off of a forecast. You look at the weather forecast, understand how cold it may get, and then turn on, spend the money on water, on running pumps all night. It can be effective, though it creates waste, but you also have the risk of not accounting for differences from where the temperature is being reported from or being measured to, a cranberry bog, which typically sees much colder temperatures than any other point around it. For wind machines, you may also want to confirm that there is, in fact, an inversion, or that warm air layer is close enough to be effective so that you don't end up, in effect, pulling colder air down onto your crops, thus increasing the likelihood of damage. And so what do you do about it? Well, our solution, and what we are here to talk to you about, is HOBOnet. So with HOBOnet, you can monitor temperatures across multiple points in your field with a single system. You can get near real-time data and alerts based off of your needs. For frost protection, for example, you lay out a few, one or two of these temperature sensors, and you decide what temperature you want to set as a threshold. And after that, after reaching that temperature point, HOBOnet will send you a text message alert notifying you of the risk of frost. So you can go to bed, you get an alert on your phone, you know that there's you're at a risky point. You can then act on that to prevent damage, or you can choose to have our stations automatically start up a pump or wind machine, for example, so that you don't even really have to get out of bed, other than make sure that that everything worked out. In addition to monitoring temperatures, you can also monitor weather conditions. We offer a wide variety of sensors. You can monitor soil moisture to help you with irrigation. So you really can get value from these stations year-round, not just during periods of frost. For many locations across the United States, you can also monitor threats of different pests and diseases. So we'll cover some applications, some actual customer applications of these. But first, I'd like to ask Matt to please give you all a quick view of what makes up a HOBOnet system, and so we can better understand what our customers are using. Matt?
Thanks, Rich. Good morning, everyone. So at the center of the HOBOnet are the stations. We have 2 stations that's compatible with HOBOnet. The first is the RX2100 series. It's a low-cost option. It's suitable for most applications in which you're looking to monitor conditions only and don't need to add capabilities such as relays, or you don't plan on adding any third-party sensors in the future. The station comes ready to use with a pre-programmed cellular connectivity. So it's very simple, integrated solar panel. Basically plug it in and you're up and monitoring. The other option that we carry is the RX3000. We have options for Wi-Fi or Ethernet, as well as cellular. This system enables you to combine remote monitoring and then add potentially a water level monitoring if you have like an irrigation reservoir or for wells or tanks. Analog inputs for third-party sensor integration. We have a 4-channel analog module. Many of our customers are using the 4-channel analog to monitor flow in pipes, or a relay module, like Rich mentioned before, to turn on your wind machine or your irrigation system. So when a frost alert is received, the relay will switch from its current state to an open or closed state, and that will trip your countermeasure. And then next slide, Rich. So we offer the basic behind your frost monitoring is obviously going to be the temperature sensor. So we offer 2 different types of temperature sensor. We have a temperature and relative humidity, as well as a temperature only option. So when you're monitoring for frost, you will not need to add the solar radiation shield, as this can slow the response time of the sensor down a little bit. So what many of our customers do, they'll opt for a temperature only sensor without a solar radiation shield, and that's going to give them the best accuracy at night when the temperature is coldest. When you're wanting to monitor for accuracy temperatures during the day, a lot of folks will add a temperature and relative humidity sensor, and they'll install that inside our solar radiation shield, and that's going to keep the sensor from heating up from the sun and give you an accurate daytime temperature.
All right, now to get into some specific actual applications or customer uses. We are located on Cape Cod. We develop all our products here and manufacture our products here, and we're surrounded by cranberry bogs. So a lot of these applications will be cranberries. So they are representative of a lot of fruits in general, especially berries. So what makes cranberries so susceptible to damage? Well, they're actually harvested quite late in the year, so late September through early November, which means that they begin to experience a lot of cold nights. Cranberry bogs are also low-lying areas, so the risk of low temperatures is much higher. As mentioned earlier, cold air flows like water and will settle in low-lying areas. Cranberry bogs, because they're a foot or two lower than the roads around them, they can actually see temperatures 8 to 10 degrees lower than those roads all around them. Though cranberries can withstand low temperatures. Late in the season, they can get down to 23 degrees Fahrenheit or -5°C. The nights can get quite cold on the bogs, so the need to protect them is real. And so to start, we can look at a simple example, the simplest, I guess, of potential applications. So one customer local to us decided to be able to monitor temperature remotely from his home. He wants to be able to know what the temperature is at the coldest point. By working with Matt, he was able to. They were able to talk about how to start off small, but make sure that they're protecting the entire all his bogs. After several years of growing cranberries, the farmer has a good feel for where the coldest temperatures would be, or where frost is most likely to develop first. And so we selected this as the location for that first temperature sensor. And as you can see on the image there, you've got the temperature point up at the top corner, north corner of his northernmost cranberry bog, right up on the corner, tucked in by the where the road would be, which basically creates an obstruction for cold air, making that a concentration point for cold air. And way out here, he's got the station collecting and transmitting that data. And so, Matt, could you go over what the tools here and cost would be?
Yeah, absolutely, Rich. So this was a very simple solution consisting of our cellular-enabled RX2100 series data logger and just a single wireless temp sensor. It's a great starting point if you're new to frost alerts or any sort of data logging equipment. This system keeps costs super low. As you can see on the screen there, the cost for this system is about $1,200. But this system will easily allow you to add up to 50 wireless sensors, as well as 5 wired sensors. So this provides a good expansion possibility. A lot of times folks will realize that maybe they need 2 or 3 temp sensors because frost could be coming in from different directions. So the cold point maybe in different areas of the bogs from time to time. And Rich, I'm going to throw in a question here. Somebody had a question about temp loggers being used in the solar radiation shield. And the question is, during the day, the temp values will be higher than the real temp. Just going back to a couple slides ago, if you're wanting an accurate daytime temperature, we definitely recommend one temperature sensor being used inside a solar radiation shield, and then an additional sensor that you would kind of ignore during the daytime, because that one's going to heat up with the sun, but at night it's actually going to provide a faster response time. Hope that answers the question there. And then moving on to another application, our customers usually take 2 paths to system expansion. Many start with a solution of just a single wireless sensor and wireless sensor and telemetry data logger for frost monitoring, like we just showed on the last slide. But others, like our friends at Fishkill Farms in New York, started with a NUA compatible weather station. So the NUA platform provides this location or site-specific disease and pest forecast for apple orchards, strawberries, vegetables, and many other crops. So for this customer, adding a HOBOnet manager to their existing RX3000 station, they were able to add temperature sensors to monitor frost events in the early spring and fall, and as well as add soil moisture sensors spread throughout their different varieties of apples and pears. Additionally, the same type of sensor, the temperature sensor, is being used to monitor their cold storage coolers and freezers, along with several greenhouses throughout the property. So if you take a look on the screen here, the main data logger or the main weather station was actually located kind of in the bottom right-hand corner there. It's marked in red. And that's when this first started, I believe it was last summer, all they were monitoring was just your typical weather parameters: wind speed, direction, rainfall, leaf wetness, temperature. But then there was the realization point that there were microclimates, further, if you look further to the top of the screen there, where these sensors or the crop in this area was actually a lot cooler than where at the weather station. So we've added a couple temp sensors, we've added soil moisture sensors, but then we really got into it and we started adding, some of the other needs was monitoring the cold storage inside, after harvest, where they keep their apples and other produce in the produce store, as well as temperatures in the greenhouse. So this system can start very simple, single temp sensor or single weather station, but it can really be expanded to match the needs of each individual site. So Rich, if you go ahead and skip down. Yep, sorry, I was talking one slide ahead there, but this is the image where it's going to show the main data logger that's in the bottom right-hand corner, marked in red, along with the frost sensors kind of on the upper portion of the screen here, and then to the left on the upper end of the screen is our soil moisture probe. And then all of the blue icons on the very bottom of the screen are representing the cold storage, the freezers, their store, along with their greenhouse monitoring. So again, one system helps them monitor in several different areas. Not only frost, not only their IPM models, but also their storage conditions.
Hey Matt, would you be able to provide any idea as to how far we're talking, what kind of distance we're looking at from the station here in red to the farthest most temperature point?
Yeah, absolutely. So the effective range of the HOBOnet sensors back to the main station, it's 1,500 feet from sensor to sensor. So this is a mesh network, and it's going to form, each sensor is actually going to act as a repeater. So in this instance, let's just call it 1,500 feet from the station in red to the sensor all the way up showing an alarm in red at the top of the screen. If that's 1,500 feet, if you were to take that point and walk a straight line north, you could go another 1,500 feet, drop a sensor. You can do that up to 5 times. So the effective range is actually 7,500 to 10,000 feet in one direction from the main station.
Great, thank you.
No problem.
And in terms of cost here?
Yeah, so this station, again, they started really with a weather station, so the cost is a little bit different here, but for the kind of focusing this on frost, this type of solution which allows for expansion possibilities. This is the RX3000 platform, the HOBOnet Manager. This provides an open module port available to add a relay module later, or a water level sensor later, or even that 4-channel analog if they're wanting to monitor, a sensor that is unique to what they're doing here. So for a system starting with frost parameter or frost capabilities that may add for system expansion in the future, you're looking right around $1,600 to $1,700.
Thank you. All right, now getting back to another common application. So water is not a viable option. So vineyards, different orchards, wind machines are likely tool. So you're basically looking at temperature and setting thresholds and alerts, much like we discussed for the berries. However, for this application or for wind machines, in addition to measuring temperature at your canopy height, you also want to add a second temperature point at about 30 feet in height, just to confirm that the air temperature the temperature of the air that you're going to be pulling down onto your vineyard or orchard is actually higher and than the temperature at the canopy height, and so you're going to actually help and not worsen the case. So in this case, you're looking at 2 different temperature points. Coming back to Cranberries, our closest customer, probably one of our longest running customers using this. You can see on the screen, similar to the first Cranberry option project that we did, this customer started with a single temperature point, but after the first year or 2, he realized that the cold patterns, because he was so close to the bay, actually weren't always consistent, and so he decided to add temperature points throughout his entire farm, and always looking for the points where we thought that the cold air would accumulate. But then in addition to these temperature points, he is also looking at soil moisture. So during the summer, he's checking on hot days, making sure that there is sufficient moisture available to the top few inches of roots and to avoid wilting. And then he also has the option to use the relay that Matt mentioned. So when he gets an alert, that alert also automatically triggers the relay to start the pumps on his in the pump house and get irrigation going. So he never actually has to even get out of bed. And Matt, this scenario here.
Yeah, absolutely, Rich. So again, a lot of these systems you're going to see kind of a reoccurring theme here, built around kind of the same platform. For this particular application, same data logger, solar panel, the HOBOnet manager, which is the wireless receiver. We have the temp sensor. But for this application, we're adding the relay module. You can see the cost in there is $120. That slides right into the RX3000. And also a pulse input adapter. What this would do is hook into like a water flow meter, and that's going to help him monitor that the irrigation is turning on, for example. So an alert from the temperature sensor would then kick the relay to turn on the irrigation, and then potentially you could use the pulse input adapter to monitor water flow through a flow meter going through that irrigation system there.
Thank you.
Yep.
So important to note that you really can start small, and as you learn more about the system and gain interest in doing and measuring different points, it is quite easy to scale up. You don't have to decide right up front everything you want to do. You can start with one thing, one value, and then add on capabilities as you go. The system allows up to 50 wireless sensors and 10 wired sensors, so we give you quite a bit of a capacity and capability. For our customer, again, one of our longest running customers for frost protection over at PJ's Cranberries, he says he's been sleeping well at night, knowing that he's protected, and our products have an eye on his property, and likes how the product has withstood the test of time in the salt air here in Cape Cod. And we're getting ready to wrap up. We're just 5 minutes over the half hour. I'd like to take a minute to do a quick poll. Jessica, if you could. All right, just another few seconds. All right, looks like half of you have voted. If you could just take another 5 seconds to let us know. And all right, I guess we can move on. Well, with that, thank you for your time. We'll take a few minutes for any questions you may have.
Hey, Rich, so one question came through. Up to what heights from ground level do the sensors measure the temperature? You want to tackle that one?
Sure. So the sensors, one advantage that our sensors have, we have a lot of them have external temperature points. So you can place them in a way that they'll measure air temperature right where you need them. So you can place one right beside budding strawberries to get that temperature 2-3 inches up off the ground. Or you can place them 10 feet up above the ground so you can get the temperature within the canopy. So you can really pinpoint where you want that temperature measurement to be.
Yeah, just to add on there, the cable for the temperature sensor that we were showing earlier, that comes with a 15-foot long cable. So that can be, you place the radio at 5 feet above the ground, so up to 20 feet, wherever you want to place it, just like Rich said.
Right, maximum quantity of sensors in the network. So our stations have capacity of up to 50 sensors or 336 data channels, whichever comes first. So for a lot of the sensors we talked about here, you would be limited by that 50 wireless sensor number, but we do have some multi-depth soil moisture sensors which would allow you to measure temperature and soil moisture up to 4 feet in depth or 5 feet in depth. So those would consume quite a few more data channels. So you'd be limited up to say 20 of those. So it really depends on the sensors you're talking about. And then you can also plug in another up to 10 sensors with our smart sensor connectors. Any other questions? All right, it looks like that's it for questions. I want to thank everyone again for your time today. I will share information, contact info for Matt again. And we do have sales managers in different territories. So Cesar Silva in Latin America, his address listed there, Don in Europe, and then Caroline Lynn Brown for Asia Pacific region. Again, thank you all for your time, and please do not hesitate to reach out with any questions. I really appreciate everyone joining. Have a great day.